Hello, good day everyone. Welcome to another section of Sky Classroom. We shall be looking at Cambridge International Exam A-Level Probability and Statistics, Paper 6 Variant 2, May-June 2023. As you can see, now the first question. In a survey of 200 students, randomly choosing students from a certain college, 23% of the students said they own a car. Calculate approximate 93% confidence level for the proportion of students from the college who own a car. Now, 93% confidence level for proportion. That's the keyword. It has a formula on its own. 90 confidence level for proportion. It has its own formula. Now, the formula for confidence, I'm going to abbreviate it, confidence interval for proportion. The formula is sample proportion P minus Z square root of PQ over N, comma, P plus Z square root of PQ over N. That's the formula for confidence interval for proportion. Now, I'm going to show you how to get the Z. How to get the Z. Remember, we have 93% confidence level. Now, let me show you using the shape, normal distribution, the dumbbell shape. Now, 93% confidence level will be at the center. So here is 93%. The remaining 7% will be distributed around the tail equally, which means this will be 3.5%, and this also will be 3.5%. When you add them together, you're going to give you 1. Now, if you want to calculate probability of Z greater than a particular value, small z, is going to be equal to 3.5%. It's going to be equal to 1 of the tail, just 1 of the tail. Probability of Z, no, this side is greater than. Probability of Z less than a particular values. If it's less than we include the 93% confidence level plus 1 of the tail, 3.5%, that's 0.35. So probability of Z less than a particular Z will be 0.965, and probability of Z less than the particular Z is the same thing as phi of Z, which is equal to 0.965. So Z is inverse of 0.965. You check your table to find the inverse of Z using your normal distribution. It's going to give us either 1.81 or 1.82. This is the Z we are going to use in the formula. Now, what's our P? P is the sample proportion. The formula is x over n. So the sample proportion P, which is x over n. What is x? X is, the person said 23% of students said they own a car. So 23% of 200, that gives us 46. So P will be 46 over 200. N is 200. Q is 1 minus 46 over 200. So our Q will be 154 over 200. So we have Q, we have P, we have Z, this is Z, and we have N. So we can now calculate the confident interval for proportion for 93% using the formula stated above. So 93% confident interval proportion. P is 46 over 200 minus Z 1.81 square root of PQ. P is 46 over 200. Q is 154 over 200. Remember I said PQ all over N. N is 200. PQ over N. N is 200, comma. So the next one is, the next interval is P plus, that's 46 over 200 plus Z 1.81 square root of PQ, 46 over 200 times 154 over 200 all over N. That's 200. That's the second interval. So 93% confident interval will be 46 over 200, I think is 0.23. So minus, when you evaluate using your calculator, we have 0.0539, comma 0.23 plus 0.0539. So at the end of the day, 93% confident interval 0.1761 and 0.2839. That's the question. So let's see the next one, number 2. Now second question is a random variable W has a Poisson distribution. W is Poisson, so it's written like this. State the relationship between mean of W and variance. The relationship is that for Poisson distribution, the mean is the same thing as the variance, and it's equal to lambda. Expectation of W and variance of W the same thing, and that lambda. That's the relationship. The next question. The next question is a random variable x is binomially distributed. You can see your T wishes to use Poisson distribution as an approximate distribution of x. Approximate distribution of x. So as an approximate distribution of x, use the formula for Ex and Vx to explain why it is necessary for P to be close to 0 for a reasonable approximation. Okay, for binomial to be approximated to for binomial to be approximated to let me check, approximated to Poisson, something like this. For binomial to be approximated to Poisson, or for better approximation, the conditions are: 1, your n must be greater than 50. The next condition is NP, the mean, must be less than 5. And for the mean to be less than 5, for better approximation, n must be very large. N must be very large. P must be extremely small. So for better approximation, like I said, n must be very large, p must be small. So p will be less than, when you make p the sort of formula, p will be less than 5 over n. Since p is less than 5 over n, so since p is less than 5 over n, and the question said we should explain why it's necessary for p to be close to 0. So it's necessary for p to be close to 0 for better approximation because n must be large, extremely large, and p must be small, minimum 5 over maximum. E.g., put n, assume n like the next question, n was 20,000. Let's use that. N is 20,000. So let's put p equal to 5 over 20,000. You see that p is equal to something like this: 0.12347. You can see 0.0007 is approximately equal to 0 because it's insignificant. So for better approximation, n must be very large, p must be very small. So if p is small and n is large, this will be justified. NP less than 5. For this NP to be less than 5, this particular NP less than 5, P must be very small. P must be very small. And N must be very large for the condition to be justified. That's what they're trying to say. Now, given that Y has a distribution binomially, remember binomial distribution is a discrete variable. Poisson 2 is also a discrete variable. So both discrete. So since they are both discrete, there is no equation of continuity. So no addition or subtraction of 0.5. Take note of that point. They are both discrete. No addition or subtraction of 0.5 because they are both discrete. So use a Poisson distribution to calculate probability of y greater than 2, which is 1 minus probability of y less than or equal to 2, which means we are going to find probability of 1 minus y less than or equal to 2. We find when y is 1, when y is 0, and when y is 2. Now, Poisson distribution, the formula of probability of, in this case, is y. Y is equal to r. Lambda, instead of x, I will say lambda raised to the power y, e raised to the power minus lambda, all over lambda factorial, which is the same thing as, when y is 0, you know we're going to have lambda raised to power 0, e raised to power minus lambda over, not lambda factorial, sorry, y factorial, that's 0 factorial, plus lambda raised to power 1, e raised to power minus lambda over 1 factorial, plus lambda raised to power 2, a raised to power minus lambda over 2 factorial. So, you know, we are doing 0, 1, and 2. At the end of the day, probability of y equal to r, where y is 0, 1, and 2 is be equal to lambda raised to power 0 is 1, 0 factorial is 1. So what left here is lambda by 0 is 1. What is left here is e raised to power minus lambda. The next one, what will be left there is lambda e raised to power minus lambda. Yep. 1 factorial is 1. Plus this one will be lambda square e raised to power minus lambda. 2 factorial is 2. At the end of the day, e raised to power minus lambda is common. What do you have here? 1. What do you have here? E raised to power minus, no, sorry. What we have here, when you factorize that, is lambda. What we have here is lambda square over 2. So since we are doing 0 to 2, this is it. If we are doing 0 to 3, you know, there will be lambda cube over 3. So like that. So probability of y greater than 2 is 1 minus this, e raised to power minus lambda. Lambda is mean. What's our mean? We don't have it yet. Our mean, lambda, is NP. You know, you are approximating. So N is, our mean is NP. So N is 20,000 and P is 0.000407. So in this case, our mean, when you multiply them together, will give us 1.4. You can see the 1.4 is less than 5, which means that we can suitably approximate binomial to Poisson using what I've done so far, because my mean is less than 5. So lambda is 1.4 into bracket 1 plus 1.4 plus 1.4 square over 2. At the end of the day, probability of y greater than 2 is 1 minus 0.2466. The one in bracket, this is 1 plus 1.4 plus this will give us 0.98. So 1 minus, when you multiply them together, add this and multiply, we have 0.83351. So probability of y greater than 2 will give us 0.166. That's it. Now let's move to the next question. Number 3. The masses in kilogram of newborn babies in country A. So this question is about country A, are represented by the random variable x with mean and variance. The masses of random sample n is 500. We have found n is 500. This is this. Calculate the unbiased mean, estimate of mean, and estimate of variance. Unbiased estimate of mean. The formula is summation x over n. And from the question, summation x is 1625, n is 500. So unbiased estimate of mean of A will give us 3.25. Variance. Unbiased estimate of variance for A. So the formula is 1 over n minus 1 bracket summation x square minus summation x square, no, summation x all square all over n. So that's unbiased estimate of variance, which is 1 over n is 500 minus 1. Summation x square is 566, 3.5. Summation x is 1625. The formula says I should square it before dividing it by 500. So from there, unbiased estimate variance for A is 1 over 499 times 5663.5 minus 1625 square over 500. So let's use our calc to find this. At the end of the day, we have 0.7660, approximately 3 signal figure 0.766. So alternatively, we can also calculate the unbiased variance. I'll do the symbol for variance using this formula: n over n minus 1 multiplied by sample variance. Sample variance is summation x squared over n minus summation minus mean. Let's try it. If you're going to give it the same thing, n is 500 over 499. Summation x squared is 5663.5 over 500 minus our mean. Our mean is 3.25 squared. Let's see. We're going to get the same thing after using the calc. Is 0.766. That's it. The next question: a researcher wishes, this is what the researcher wishes to do. He wishes to test whether the mean of mass of newborn baby in neighboring country B is different from that of country A. He wishes to test, which means that the null hypothesis is that the mean of A is the same thing as mean of B, while the alternative hypothesis is what he wishes to do. He wishes to do it to test if they are different. Stated, this should be 1 mark. Stating hypothesis. He chooses a random sample. Now for B, he chooses a random sample. For B, n is 60, and find the mean, sample mean mass to be 2.95. The sample mean for B is the sample mean is different from the mean. Sample mean is bar x, that's 2.95. This is still for B. Assume the unbiased estimates are correct for value of mean and variance in A. Okay. Also assume that the variance of masses of newborn baby in B is the same as in A. So the variance of B is the same as A. I remember that the variance we calculated earlier, the one for A is 0.76660. It's the same thing as B. These are the parameters for B. Carry out the test of one significant level. Now, one significant level. Now, 1% significant level is the same thing as 99% confidence interval. 1% significant level, the same thing as 99% confidence what? Interval. I'm coming back to that. Now, let's analyze this question. It's a 5 marks question. Now, for this case, there are some conditions, there are some observation. I have some observation for this case. They never mention that it's normally distributed. That's number one. This case is not normally distributed. If you check the question or two, never see anything like that. True. Population variance. Population variance. Population variance is known. Check it. And 3, sample size. Sample size is greater than or equal to 30. These are my observations. With these 3 observations, it leads us to something. Whenever a question in population like this is not normally distributed, population variance is known and sample size is greater than 30. It's simple. You apply central limit theorem. Apply central limit theorem, CLT. What is central limit theorem? Central limit theorem is the sample mean is normally what? Is approximated. Yeah, sample mean. Sorry, central limit theorem means that central limit theorem means that the sample mean is x by x is approximately normally distributed or distributed normally. That is the theorem, CLT. The sample mean is approximately distributed normally. So the sample mean will be in this form: mean and variance over n. This is it. Where the test statistics will be sample mean minus mean all over standard deviation over square root of n. That will be the test statistics to use. This is all the parameter for CLT. Now, let's go back. 1% significant level mean 99% confidence interval. Like I said, draw your dumbbell shape. 99% confidence interval at the center. In the previous question, that's what I did. 99%, 0.99. The remaining 1% we distributed equally around the tail. That will be 0.005, 1% divided by 2, and 0.005. That's it. So this region between here and here is the acceptance region. Why? This point here is called critical value. This point, critical value, is called critical value. So this side is the rejection region. This side is the rejection region. This side is the rejection region. I remember that critical value here is 0.005. Let me take this one to be negative, this one to be what? Positive, this side. Now, and like I said earlier, what we are concerned with is probability of z less than z. For less than, I told you less than, we take the confidence interval plus one of the critical region. So probability of z less than z will be, that small z is a certain value, will be let's add it together, 0.99 plus 0.05, 0.99 plus 0.005. What we have is 0.995. 0.995. So when you check your, which is phi of z equal to 0.995, when you check your table, your MF19, it's been given there under the normal distribution function. Down there you see critical value for normal distribution, small table. 0.995 is given as a phi of 0.995 is given as 2.576. We use the table and find it normally, as in no, sorry. Is when you find the inverse of phi, we have this. So in that case, z is 2.576. So 99% confidence interval, which is the same thing as 1% significant level, will give us 2.576. Let's now let's see what the test starts. Let's see what the test statistically will give us. This is it. No, it's for sample B, for country B. The sample mean for country B is giving us 2.95. We assume to the mean to be the same as mean of A. That's 3.25. All over square root of standard deviation, which is 0.766 over the number of B, which is 60. Remember that this variance of A is the same thing as B according to the question. At the end of the day, your T start when you evaluate will give us minus 7.1. So where can you find this minus 7.1? Where can you find this minus 7.1? Minus 7.1, 7.1, you know, this Z is 2.576, okay? Minus 7.1 is around this region. You know, this is minus 0.05. This space is minus 0.05. So let's say here is 0, here is 1. So minus 7.1, let me change it to color. Minus 7.1 would be in this region, this side, maybe somewhere here. Minus 7.1, but this is minus 0.05, this place. So minus 7.1 will be down the left, down the left. So at the end of the day, so minus 7.1 falls in the rejection region. So the conclusion is that reject H0, which means they are not equal, which simply means mean mass of newborn babies, mean mass of newborn babies is different from that of country A. That's it. believe it's clear. Let's move to the next one, number 4. Number 4 question. Now, state the number X of books received at the charity shop has a constant mean of 5.1 per day. State in context one condition for X to be modeled by Poisson distribution. Okay, it's because it occur at a constant rate. That's a model. Assume now that X can be modeled by Poisson distribution. Like the first one said, occur at a constant rate, 5.1 per day, which means 2 days will be 5.1 times 2, 3 days 5.1 times 3. That's one of the conditions for Poisson distribution. It occur at a constant rate. It's like uniform. So if I'm going to even write this, represent it in the Poisson form, it will be X 5.1. Now, assume now that X can be modeled by Poisson. Find the probability that exactly 10 books are received in 3-day period. If per day is 5.1, so 3 days 5.1 times 3. So for 3 days will be 15.3. The mean is not that big. We have the condition that state that when lambda is greater than 15, some will say 15, some will say 30, but the key is when it's greater than 15. Greater than 15 means greater than 15 in context is like 20 above, 20 or 18, but in the range of 15 we are still good to go, not to approximate it. I believe that. Find the probability that exactly 10 books are received in 3-day period. When the mean is now 15.3, exactly 10 books. Okay, exactly 10 books. Poisson is the formula is lambda raised to power x e raised to power minus lambda over x factorial. So which will give us lambda is 15.3 raised to power 10, 15 e raised to power minus 15.3 all over 10 factorial. So which will give us 0.0439, approximately 0.044. I think this is it for 2 marks. I don't think they expect it more than this. And I'm very sure it cannot be approximation. It's a 2-mark question. The mean is not significantly large. It's 15.3. The range of 15. This is correct. C. Use a suitable approximating distribution. Now, we have to approximate to find probability of more than 180 for a 30-day period, more than 180. Greater than 180. Now, greater than 180 for a 30-day period. So let's see the Poisson for a 30-day. 1 day is 5.1. 30-day is 5.1 times 30. In this case, the Poisson is the mean is 153. This is significantly greater than 15. Since it's greater than 15, we are going to use approximation. So the approximation is Poisson will be converted. We approximately use as normal. In this context, the mean for normal and the variance for normal, they are the same thing for Poisson. Normal is always like this, mean and variance square. In this case, the mean is lambda, the variance is also what? Lambda. So, and what's the formula to standardize? X minus mean over square root of standard deviation. In this case, Poisson is discrete, normal is not discrete, it's continuous. When you're converting from discrete to continuous, don't forget your continuity plus or minus 0.5. That's your continuity. Let me give you some key parts for continuity. If you have greater than x, we're going to add 0.5 to x. If you have greater than or equal to x, subtract 0.5. If you have less than x, subtract 0.5. And if you have less than or equal to x, add 0.5. Let me stop here for now. And this one is greater than 180. So probability of z greater than 180, that will be 180.5 minus our mean 153 over square root of variance, square root of 153. So we have probability of z greater than, and when you do the stuff, you're going to have 2.22, something like this. So which is 1 minus 5 of 1 minus 5 of 1 minus 5 of 2.2 under 2, yeah. So that gives us 5 of that. We check your table, 0.9869. That gives 0.0131. That is the answer for a 30-day period. Probability for a 30-day period. Now, 30-day period for more than 180 books. This one is exactly 10 books. Exactly 10 books. Now, D question. The number of DVD received at the same shop is model independent Poisson. For DVD is model independently. Now, for DVD is model as Poisson 2.5 per day. Find the probability that the total number of books and DVD received at the shop in one day, just one day, the mean is just 2.5, is more than, for DVD, I'm looking for probability of more than 3. More than 3 will be equal to 1 minus probability of less than or equal to 3. The formula I gave earlier in previous question, like this, if you remember, 1 plus lambda square plus lambda square over 2 factorial, lambda cube over 3 factorial. So we're going to have, for DVD, 1 minus, the mean is 2.5, 1 plus 2.5 plus 2.5 square over 2 factorial plus 2.5 cube over 3 factorial. So we have 1 minus 0.757976, approximately 0.2424 for DVD. For books, it's also modeled independently, the same thing. For books, the mean per day for book is 5.1 in the previous question. E raised by minus 5.1, 1 plus 5.1 plus 5.1 square over 2 factorial plus 5.1 cube over 3 factorial. So we have 1 minus 0.2513 if evaluated, which gives us 0.7487. The question, if you do the question, it asks us for total number of books and DVD that are received in that shop when you model them like that. So the total will be 0.7487 plus 0.2424. Let's add them together. 0.7487 plus 0.2424. So we have 0.9911. That's it. I believe it's clear. So two random variables, x and y, have independent distribution, normally distributed anyway. So x is normally distributed, that's 7 and 3. So if I say 3 square, that will be variance. Okay, that's x. Y is 6, 2, mean and variance. So the question asks us that find value that the two values differ by more than 2. Okay, the difference 2 will be normally distributed. The difference between the two means 7 and 6 is 1. There's no subtraction in variance, it's only addition. You have to add them. 3 plus 2. Add them, that's 5. We don't subtract variance, we can only add variance. So this is the difference, D. The question asks us to find probability that the difference is differ by 2. The difference between x and y is the two values differ by more than 2. It can be like this, or it can be, they didn't tell us x minus y, so it can be x minus y or y minus x, but the difference has to be a modulus anyway, greater than 2. This is what they refer to anyway. So standardizing it to the probability of z, the difference is greater than 2. Greater than 2, that'll be 2 minus 1. If you are using standardization, x minus mean over square root of standard deviation, the square root of variance anyway. So x is 2 minus 1, that's the mean, all over square root of 5, plus the same thing, z greater than 2 minus 1 over square root of 5. The key to this question is interpretation. The probability that the two values differ by more than 2. So from here, probability will now be z greater than 1 over root 5 plus z greater than 1 over root 5, which is greater than is 1 minus 5 of 1 over root 5, 1 over root 5, that gives us 0.4472 plus 1 minus 5 of 0.4472. So we have 1 plus 1 is 2 minus 2 phi of 0.4 under 47. Let's feel like that. So that will be so probability of x minus y greater than 2 plus this. So it will be 2 is common. Let's just say 2. What's the phi of 0.447? That's 0.4 under 4. 0.4 under 4 give us 0.6700. So plus add on 7. Add on 7 give us 25. So 0.0025. That gives us 0.6725 multiplied by 2. So that will be 2 minus 1.345. So 2 minus 1.345. That gives us 0.655. That's the probability. Okay, let's move to the next one. Now, each candidate's overall score in a science test is calculated as follows. The mark for theory is denoted by T, and the mark for practical is denoted by P, and the overall score is given by T plus 1.5P. Overall score. The variable TRP are assumed to be independent with distribution. Okay. T is normally distributed as mean and variance, while P2 is normally distributed as mean 42, variance 108. Now, you should assume no continuity correction are needed when using this distribution. Okay, a pass is awarded to candidate whose overall score is at least 90. Find the proportion of candidates who pass. Overall score, probability of candidate who pass, T plus 1.5P is greater than, so at least 90. So you have to look for, since T and P are normally distributed, so T plus 5P, T plus 1.5P should also be normally distributed. So, and the property of normal distribution is mean and variance. So you need to look for the mean of T plus 1.5P and also the variance of T plus 1.5P. So the mean, which is this, you have to do this plus 1.5 this. So what is the mean of T? 62 plus 1.5. Mean of P is 42. At the end of the day, we have 125. That's the mean of T plus 1.5P. It gives us 125. The variance of T plus 1.5P should be variance of T plus variance of 1.5P, which should be written as this: variance of T plus 1.5 square variance of P. So variance of P is 158. 1.5 square variance of P is 108. So let's use our calc. 1.5 square times 108 plus 158, I guess. Yeah, 401. So variance of t plus 1.5p is 401. So the total mark, which is t plus 1.5p, also is normally distributed. Since individuals are normally distributed, the total should be normally distributed with the mean of 125 and variance of 401. For the question asks us to find probability of the total mark greater than or less than, greater than or equal to 90. So probability of z greater than or equal to 90. 90 minus mean all over square root of the variance. I use this formula, z x minus mean over square root of this. So probability of z greater than or equal to, so 90 minus 125 divided by square root of 401. So we have minus 1.7478. So probability of z is greater than or equal to this. The same thing as probability of z greater than this. It's the same thing, the same approach. And probability of z greater than minus 1.7478 is 1 minus 5, 1.748, which is 1 minus 5 of 1.7, 5 of 1.7. That gives us 1.7 under 4, 0.9591, 0.959591, I guess. 1.7 under 4, 9591. Trace it under add 8. Add 8 is 7. That's plus 0.0007. So we have 0.9598. 0.9598. So 1 minus 0.9598, that gave us 0.0402. That is what. Okay. Oh, hold on. For the question asks us to find proportion of the candidate who pass. This is the probability of the candidate who pass. I think the proportion is like percentage. Let me asterisk it. That will be most likely 0.0402 times 100. I think so. That should be 4.02%. Approximately 4%. I think so. Now the next one. Comment on assumption that the variable t and p are independent. Comment on the assumption that the variable t and p are independent. Okay, assumption. Oh, okay, this is what I think they're trying to say. The sum of two independent normally distributed random variable with normal is normal, with mean being the sum of t and p and variance. Yeah, exactly. I think so. The sum, let me put it down. The sum of two independent two independent, normally distributed, random, random variable is normal. Yeah, the sum of T and P. That's the assumption that I made. Is normal with mean being the sum of mean of T, the sum of mean of T and mean of P, and variance being the sum of variance of P and variance of T. That's the assumption. Number 6, the hypothesis question. When a child completes online exercise, when a child completes an online exercise called Mathlit, they might be awarded a medal. They might be awarded a medal. It's not compulsory. The publisher claims, that the probability that the randomly chosen child who complete a Mathlit will be awarded a medal is 1/3. Asha wishes to test this claim. This person wishes to test the claim. She decided that if she is awarded no medal while completing 10 Mathlets, she will conclude that the true probability is less than 1/3. That's if she's now she decided that if she's awarded no medal, this is the rejection region, no medal. If she's awarded no medal while completing or after completing 10 Mathlets, she will conclude that the true probability is less than. That's when she will conclude that the true probability is less than 1/3. In this case, the null hypothesis probability is 1/3. The alternate hypothesis is less than 1/3. Now look at the rejection region here. The rejection region is that she decided that if she's awarded no medal, rejection region. If she's awarded no medal after completing 10, then she will conclude that it's less than 1/3 if she's awarded no medal. Now, use binomial distribution to find probability of type 1 error. Use binomial distribution to conclude probability of what? To find probability of type 1 error. Binomial distribution. The conclusion is that after completing 10 Mathlets, she will now conclude that probability is less than 1/3. So probability of success in this case is 1/3. Now, what is probability of type 1 error? That's the first question. Probability of type 1 error means reject H0. Reject H0. Why H0 is true. That's the meaning. So probability of type 1 error. Type 1 error will be, now what's the rejection region? Reject when x is 0, where H0 is true. That's 1/3. So using the formula, hence, binomial n combination r, p raised to the power r, q raised to the power n minus r. So hence our n is 10. R is 0. Probability of success is 1 over 3 raised to the power 0. Failure 1 minus 1 over 3. That's 2 over 3 raised to the power 10. What do you have? 0.017. This is probability of type 1 error. Reject H0 when H0 is true, and the rejection region is when X is 0. H0 is true. That's success is 1 over 3. So X is 0, P is 1 over 3. Put inside the formula for binomial. That's the probability. The next question. Now, the true probability of being awarded a medal is denoted by P. The true probability of being awarded a medal. If you are going to be awarded any medal, the probability is P. Given probability of type 2 error, probability of type 2 error is 0.8926. 0.8926. Sorry. Find the value of P. Now, what is type 2 error? What's type 2 error? Type 2 error means probability of what? Accept H0 when H0 is false. Now, and accept will be opposite of rejection region. Rejection region is when X is 0. Rejection region is when X is 0. So the acceptance region will be when X is greater than 0. Opposite of rejection. And in this case, when H0 is false. So I'm looking for when H0 is false. I don't know that. You can see the true probability of being awarded the medal is noted by P. In this case, is P. I don't know it. And the probability is 0.8926. Now, first, probability of when X is greater than 0 should be 1 minus probability of X less than 1. How? It's 10. It's 10 Mathletes exercise. Let me list it so you can see. And let me, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm looking for probability of when X is greater than 0. The opposite, when X is less than 0. All these ones are greater than 0. They are all greater than 0. So when it's less than 0, it's probability of when X is 0. So probability of when X is 0 plus probability of when X is greater than 0 will give us 1. So, sorry. So from here, probability of X greater than 0 will be 1 minus probability of when X is 0. So we can now solve this. Since for type 2 error, probability of when X is greater than 0 to P is 0.8926. In this case, using the formula, that's 1 minus n. N is 10. X is 0. Combination 0. Our probability is P. raised to the power 0. Q is 1 minus P raised to the power 10 minus 0 equal to 0.8926. I believe you're following. So from here we have 1 minus 10 combination 0. 10 combination 0. Let me look for it in calc. I think it's 1 also. Second function 10, second function combination 0. We have 1. 1 times 1 is 1 minus P raised to the power 10 equal to 0.8926. At the end of the day, we have 1 minus P raised to the power 10 equal to 0.8926. So 1 minus P raised to the power 10 minus 0.8926 minus 1. I'll give 1 minus P raised to the power 10 equal to minus 0.1074. Minus cancel minus. 1 minus P is 0.1074 raised to the power 1 over 10. So 1 minus P will give us, let me check it, 0.1074 raised to the power 0.1. That gives us 0.8. That gives us 0.8. From here, minus P 0.8 minus 1 minus 0.2 minus cancel minus. So in this context, P is 0.2, which is 1 over 5. So the probability of being awarded a medal, okay, I believe it's clear enough. Don't mind my rough work there. I'm trying to manage space. So I think my network is punctuating. We have one more question. I need to divide into 2 and do it as second part in the next few hours or few minutes. Number 7, that'll be the next part. Thank you. Please subscribe to my channel, share it. There are more interesting content coming. I'm still going to do fundamental level. I'm going to do AP, calculus, physics, electromagnetics, induction, physics C. More content are still coming. Subscribe to the channel.